So let's talk through the steps that you'll need to do for each hypothesis test. And we'll also talk about all of the different scenarios that could come up. So different resources, different books will have a different layout of steps, but all of these pieces should be in there. They might just be separated differently. The first thing we have to do is state null and alternative hypothesis. So from this, you'll go through the wording of the problem and look for information about what they're assuming is true or what they want to test. In the null hypothesis, you'll always have P equals and then some number. And this statement is what we assume is true. Then for the alternative hypothesis, this is where in the wording of the problem you want to look for some keywords like test or evidence, because this is what we want to prove. So look for wording of test or evidence in the problem, and those will typically give you an idea of what we're trying to test or find evidence for. Now this is going to take P, it's going to have the same number there, and then in between there's three options for your symbol: more than, less than, or does not equal. And then you just have to choose the symbol that matches the wording of the problem, but you'll only ever use one of them. Then our next piece is to check the conditions, and then I also throw in this little setup piece that I'll talk through as well. But for checking the conditions, you want to check independence, randomization, and then success failure. And just remember with the success failure part, you're using the proportion from the hypothesis, from the null hypothesis. So we want to take our sample size times our hypothesized proportion and make sure that's more than or equal to 10. Then take your sample size times 1 minus that proportion, and that should also be more than or equal to 10. Now, in the setup stage, this is where I just draw myself a little picture. Since you're in this spot of just setting things up, it can be helpful to draw a picture. What I mean is just kind of recognizing, are you doing a right tail, left tail, or two-tail test? Especially when you do a two-tail test, this step can be helpful to make sure that you're calculating p-value correctly. So I only ever draw one of these pictures, but you look at your alternative hypothesis and look at what scenario do you have. Do you have that you're trying to prove that p is more than some number? Are you trying to prove that p is less than some number? Are you trying to prove that p is just different from some number? And with that, that'll set up the type of test that you're doing. I'm just going to move those over. Because if it's the more than, then you have a right tail test. So what I would want to do is just draw a quick sketch that'll help me once I'm in GeoGebra to see, once I'm in the GeoGebra, I'm going to have this area to the right. Wherever my sample statistic lands, or specifically my test statistic, my z-score will land somewhere to the right over there, and it's that shaded area that tells me p-value. So then I can see how I'm going to calculate my p-value once I'm in and using technology. This next case is the left tail test, so same idea. Then you'll just be in GeoGebra, and you'll have this z-score that lands you somewhere on the left-hand side. And to find p-value, you want the area to the left. And then with the two-tail test, this can be helpful to see a picture so that once you find that tail area, you remember to take 2 times that area. So the two-tail test, you'll either be already finding a left tail or a right tail, but whichever one you're finding, you want to multiply that number by 2. So then once you get that p-value out, that tells you that you will reject the null hypothesis if your p-value is less than or equal to whatever your significance level is. So this is just a little step that I do to help set up visually what we're going to calculate, especially once we're in GeoGebra. We want to make sure we go in the right direction with p-value. So finding the test statistic and the p-value to evaluate. This one I do kind of 3 little sub-steps. First thing is find that test statistic. So the test statistic is going to be that z-score that we need. And to calculate that z-score, you want to use that formula z equals. We take our sample proportion minus the proportion from our null hypothesis divided by that standard error formula. So null hypothesis proportion times 1 minus that value over sample size. Now, the thing that gets mixed up most often with this equation is the denominator. Students often want to use p hat and q hat using our sample data as the numerator down there, but we do not want to do that. Again, we're trying to build everything around the idea that the null hypothesis is true, and to do that, we want to use the standard error that would come through those values. So, again, with this whole process, the only spot you use that sample data is just right there in the numerator. That's the one spot you plug it in. Everywhere else is about this proportion and the null hypothesis. All right, then for our next piece here is to find the p-value. And this is where we go to GeoGebra. So, or any technology that you're using. But you're going to use your standard normal curve and then use that to create an area by using the picture up above. That's why in step 2 I like to draw a little picture, because I know to create an area that matches what I'm looking for up above or matches what you described in the alternative hypothesis. So outlined in part 2 with the test statistic. So this is where you plug in z and see what is the actual area that comes out. And then the last piece here is to figure out what's going to be in our conclusion. This is where we evaluate. And you're going to compare your p-value to the significance level. If it's larger than the significance level, then we failed to reject the null. Which means no evidence for the alternative hypothesis, which is the wording that we would actually use in our conclusion. If our p-value is small, then we reject the null hypothesis, which means we do have evidence for the alternative. So those are our little 3 sub-steps. First, find your z-score. Again, just be careful using technology with that. In the example before, I used Desmos Scientific Calculator, just organizes it very clearly. Then in part 2, you go into GeoGebra and find the area under the curve for the p-value, and then evaluate whether or not you reject that null hypothesis. Now, in terms of conclusions, there is kind of a structure that you want to follow. I mean, there's very many different ways to word them, but you can kind of follow this rule of, say we came to the conclusion that we're going to fail to reject the null hypothesis. For our wording, we'd want to say something along the lines of, with a p-value of, and then whatever number we found for our p-value in step 3. And this is a case where we don't have evidence for the alternative. So we would say there isn't evidence for, and then the rest of the wording is just wording for the alternative hypothesis, which is most often stated somewhere in the wording of the question itself. So you'll want to fill in the blank there with whatever's coming from the context of the question. And the other scenario, which is when we would reject the null, is going to look very similar. We basically just change one thing. We would still say with a p-value of whatever number it is. And then instead of there isn't evidence, now we do have evidence. So we would just say there is evidence for, and then whatever our wording for the alternative hypothesis is. So those are the steps we want to follow. Start with that null and alternative, check your conditions, figure out do we have a right tail, left tail, or two-tailed test, calculate that test statistic, use that to find p-value, and then figure out if p-value is small or large, and that'll lead us to our final wording. All right, in the next video, I'll go over some examples.